One way to think about an even function is that its graph is symmetric about the y-axis. Okay, so if you were to fold the graph here along the y-axis, you see that this piece will match up exactly with this piece. Same with this graph over here. It's symmetric with respect to the y-axis because if you fold it along the y-axis, these two pieces will match up. Well, at least I tried to draw this one exactly like this one. Okay, another way to think about even functions is the following. Okay, and this will be a more algebraic way. So let's take a look at the y value here when x is equal to 1. It's up there at 2. When x is equal to negative 1, the y value is also 2. So that means that f of 1 is equal to f of negative 1. Likewise, if I look at the y value when x is equal to 1/2 here, and when x is equal to negative 1/2, the y value is there. These two y values are equal. So that says that f of 1/2 equals f of negative 1/2. Okay, so the same is going to be true for an even function for any x value that we choose. The y value that we get for x is always going to be equal to the y value that we get for negative x. Okay, so you see that it's the same over here. At 1, the y value is here. When x is negative 1, the y value is here, and so on. Negative 2, it's here. Positive 2, it's here. Okay, so this is an important algebraic property about even functions, that f of x is equal to f of negative x. Okay, now let's take a look at odd functions. Odd functions have a very nice property, which is that they are symmetric with respect to the origin. What that means is that if we take the graph and we spin it halfway around in this direction, this graph, this portion of the graph, is going to meet up with this portion of the graph. Likewise, if we see over here, if we take this guy, spin it halfway around, then this graph is going to match up with this graph. Okay? Another way of thinking about odd functions is from an algebraic point of view. So let's take a look at the x value of negative 2 and the x value of 2. F of negative 2 is negative 2. F of 2 is 2. So it means that this y value here is the negative of this y value. Again, that says f of negative 2 is the negative of f of 2. Likewise, here is the y value when x is negative 1. Here is the y value when x is 1. F of negative 1 is the negative of f of 1. More generally, we have for odd functions, f of negative x equals negative f of x. Okay, so this is an important algebraic property of odd functions. Okay, let's take a look at some examples. Let's determine whether this function here is odd, even, or neither, because not all functions have to be one or the other. They might not have any kind of special symmetry. Because of these exponents, 4 and 2, I'm thinking that this function is going to be even. So let's find out. What we're going to do is we're going to take these two x's and replace them with negative x. So we get 3 times negative x to the 4th plus 2 times negative x squared. Negative x raised to the 4th power is equal to x to the 4th power, because when you raise the negative 1 to the 4th, you get an even number. You get positive 1. Sorry, not even, but a positive number. Negative x squared, likewise, is equal to positive x squared. So we see that f of negative x is actually equal to 3x to the fourth plus 2x squared. And that's what f of x equals. Okay, so this here is equal to the original. So that's saying f of negative x is equal to f of x. So that tells us that this function is even. Let's take a look at another example. Okay, just like before, we're going to start by replacing x with negative x. So we get negative x quantity cubed minus 4 times negative x. Negative x quantity cubed is negative x cubed, and this is plus 4x. What we see is that this function is actually the negative of the original. Okay, if we factor out a negative here, we get positive x cubed minus 4x. So this function here is an odd function because f of negative x equals negative f of x. Okay, let's do one more example. Replacing x with negative x, we get negative x to the fourth plus 2 times negative x cubed. Negative x raised to the fourth power becomes positive x to the fourth power. Negative x raised to the third power becomes negative x to the third power. So we get x to the fourth, because this is a plus, I just scribbled it down, minus 2x cubed. Okay, well, this is not equal to the original function, and it's also not equal to the negative of the original, because the negative of the original would be negative x to the fourth minus 2x cubed. Okay, so it's neither even nor odd.